Hey Sheldon, it's just a quick update for you. So, still waiting on a couple components here, but waiting on a couple transistors similar to this. These ones burnt out. I overvoltaged them and maybe they weren't designed for, I don't know. It's difficult to read the specs on the data sheets regarding that stuff. But one of the problems I was always having was the size of this guy left to right. To the center for the wheel especially, it was very difficult to get to when you don't have a drill press with a large enough swing. There's this one. So this one's a Delta. It's got about 4.5, 5 inches to this nut here. It's called the swing. And that's just not deep enough because everything I'm building has got, at least 8 inches from the center of the axle to the outside. So I couldn't get it in deep enough to make sure that was centered properly. But I've solved that and we have a solution in place here now. I just finished edging this up. So this is my portable drill press. I can slap this down on anything, any size. And it's all wedged and checked out and I can tap it in, make it stronger. But this ain't gonna move, and it's pretty damn the closest I can get to guaranteeing a 90-degree angle. So that should be good. And then the next part is here's the roll of copper I got. It's 28 gauge, 5 pounds. Thank you so much. We're going to start taking this apart and we're going to fill up this coil similar to this. And the way I'm going to do this is this was a pump that I designed with an AC-DC converter. So this will convert AC-DC 120 or 140 volt to 120, and it rectifies it in a way that allows you to switch it on and off, forward and back, and control it through potentiometer. So you can see here, I control speed. It's got a very, very strong 16 times gearbox in here, so it's really, really stiff. Like it don't want to stop. It'll just work harder. And so I can slow it down, but I can also, there's a finger, switch it the other way, turn it back on, and it's going the other way. So that'll be handy. Not totally necessary. So middle's the off, and we have nothing. I'm just going to unplug that. But you can see I'm working on solutions to try to solve some of these problems because I don't just have one of these to do. I've got a whole box full of them. There's 16 in total. 15 in here and one on the table. And so that will be the next challenge, is get these guys wound. At least I have to wind one of these up a fair ways. Once I have it wound up and I'm comfortable with how much is packing it, I'll test it for ohmage, and we want to make sure that it's below 10 ohms. Once we can see it's below 10 ohms, then I'm going to unravel the entire length, find out what it is, square it up to, a square foot, 250 wind or 250 feet or so, and then I'll rewind it, but I'll count the number of windings. The length of the feet is most important to me. This is 34 millimeters in diameter, and then it just gets wider and wider as it gets packed on. So that's not as important to me. But knowing how long it's going to be, as far as I know, is the only thing that really matters to me at this point. But we'll take this 28 gauge, we'll get it wound up, and we'll take the length of this, divide it by 16 in total, and see whether or not we're going to have enough. Because your idea of getting 3 of these is not such a bad idea, but obviously there was only one available. So you take what you can get, right? But we can learn from this for starters. We can figure something out. But that's the next step. At any rate, wish me luck, bud. Bye-bye.